I'm going to be in Hornell. Okay. Determining the number of types of atoms and valence electrons, they went together. We arranged our skeletal structure. Remember, it's typically the first element in the formula that's going to be our central one, unless it's hydrogen. Then we, once we added the skeleton structure, we put those bonds in and subtracted those out. We added lone pairs. If everything got to our octet rule being filled with those extra electrons that became lone pairs, we were good. We didn't have to do anything extra. But at the end of class yesterday, we said, well, what if you ran out of electrons? What if you ran out of electrons and you didn't have any more to make lone pairs? What do you do then? What did we then form? Double or triple, right? That's when we formed our multiple bonds. That was kind of step 5B. We formed those multiple bonds. Now remember, this is a last resort. You only make multiple bonds when you run out of electrons to add to your system, add to your structure. Okay? Now, which do you think they're going to want to form first, double or triple? Why double over triple? It's easier, right? What's the whole idea, guys, of bonding? They want to be in the lowest what? Energy. They want to use the least amount of energy possible. Well, think. Double has how many electrons? It's got 4. Triple has 6. So right there, a triple takes a lot more energy. So if possible, structures will want to form double ones before they form a triple. Triple is your absolute last resort. All right, so keep that in mind. So here we go. We're going to try carbon dioxide together. We only did one example together. We did the CH2O in your notes. So we're going to pick up right where we left off. What page is this? 11. Page 11. So first step is first. What do? Figure out what? What are we going to figure out? Valence electrons, right? Carbon has how many? 4. Oxygen has 6 times 2 is? Why did I say 2? Because there's 2 oxygen atoms right there. So we've got a total of 16 electrons. Same process we've done. Okay, there's steps 1 and 2. Step 3 is to figure out our central atom. What's my central atom going to be? Carbon. Put my oxygens around it. Connect them with a bond. There's my skeleton structure. Subtract out the ones I used for bonds. So I've got 12 more. Which atoms do I start putting dots around first? The satellite ones, which are the ones outside the centerpiece. So I'm going to start with oxygen. Each oxygen needs how many more? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, that's 12 total, which is all I had. So now I ran out. I can't add any more. Are all my atoms happy? No, right? Oxygen, each oxygen's got 8. Carbon only has how many?
4.
It's only got 4. So, we ran out of electrons. Now what are we going to do? Where are we going to get electrons from? From the oxygen. So, right now, when we look at this structure, there's still a lot of energy. There's still a lot of strain on it because carbon isn't satisfied. It's not following the octet rule. It's got an unfilled shell. So oxygen is willing to say, hey, carbon, take some of my electrons so that you can be satisfied. I'll still be happy, and that we'll all be happy together and be in lower energy. Okay? So oxygen is very willing to share more than just one of its electrons with carbon to make it happy. Very nice, right? Is that what you said? Yeah, I know, right? Except when they blow up. Then they're not really sweet. All right. Now, where are we going to get those electrons from, do you think? We got a lot of options, don't we?
Lone pairs.
Yeah, but which lone pair, right? We've got 6 lone pairs we could take them from. So we could do this right here. We could take one here. We could take that. Do you think that's the structure that we're going to want to form? Because what would that form? A triple bond. So the question is, do we want to form one triple bond and a single bond? Or do you think we're going to want to form 2 double bonds? Yeah, absolutely, guys. 2 double bonds. If you just look at it, it looks a lot different by forming a triple. It's kind of uneven. They want to be as even as possible, lowest energy. So each oxygen is going to contribute a pair of electrons. So now our new structure is going to look something like this. We've got a double bond between it. Now, we haven't done the lab yet in this class, and that's okay. Do you think this is what my structure is going to look like?
Yeah.
Why do you think that's the way it's going to look like? Okay, it looks even. But notice how it's got this shape right here, right? It's kind of bent there.
It's like an L.
Yeah, it's kind of like an upside down L, right? But does that look right?
Sure.
Think about it. What's in here, guys? What's in these lines? They're bonds which have electrons. What do we know about electrons? They're negative. What do we know about negative charges? They want to repel. Do you think that these electrons are going to be this close to each other if they could spread out more? No, they want to spread out, and that's exactly what they're going to do. This is what we're going to start looking at next period in lab. This structure would actually look something like this, where you're going to have the two oxygens on opposite sides of each other, because again, they are repelling. This is what we call VSEPR. Valence shell electron pair repulsion. Repulsion. They are repelling each other away. You guys are going to investigate in lab next period what happens when you add electrons into a structure, right? More bonds and things. So keep that in mind. So you guys are going to go ahead and try HCN right now. So when we take a look here, guys, there's the calculation you should have for your valence electrons. We've got 10 electrons we've got to use. What's going to be my central atom here? Carbon. Why not hydrogen? Because it only needs 2. So one bond, we skip over that. Carbon is my central atom. Then I'm going to put around the other 2 atoms that I have. Connect them. We'll get there. It's okay to do it like this, the first one. Your final structures where you want to make sure you show the shape. Absolutely. But the more you draw the structures, guys, the more you will see it to where, hey, I can kind of say, oh, I know this is going to have to go over here like you were saying, then it needs to be straight. Okay? So, the other electrons are going to go around nitrogen first. Satellite atoms first, then your central one. Well, that eliminates all other 6. Carbon's not happy. What do we have to do? Make a multiple bond. In this case, it's going to be a triple bond. So now notice, I took from this one. Doesn't matter where you get those electrons from. But notice here, I left this this lone pair of electrons over here. Do you think it's going to stay on this side of the nitrogen? Why not? Because again, it wants to repel. It'll still move as far away from the bond as possible. So our new structure would look like this. There's going to be a triple bond between the carbon and the nitrogen. Okay? This would be a straight line. We're going to learn again next period what that means for us. And again, those electrons, that last lone pair is going to get shifted away. Notice how I kind of moved my electrons up here off to, like, instead of being on the sides of oxygen, kind of angled them. Okay? That's something that we're going to see as well, that those lone pairs may shift just like a bond would. Okay? So, is this anything new as far as our steps go? No, we ran out of electrons, so we do one extra thing and form a multiple bond. Remember, that's a last resort when you run out of electrons. So, that's the 5 steps. There's one additional step we got to learn about, with these things called polyatomic ions. Now, we have not gotten to those yet in the course. Next unit, Unit 5, you're going to have a whole list of them. You're going to have certain ones you have to have memorized, just like I had you guys memorize certain elements on the periodic table. So you'll have a polyatomic ion quiz coming at some point. We're going to be using them all throughout the year. For right now, within this unit, if I give you one, I'm going to give you the formula. You won't have to know the name. Next unit, starting next week, you'll have to start memorizing the names and the formulas. But let's just break that term down. Polyatomic ion. Poly means what, guys? Many. Atomic is referring to atoms. So there's many atoms, and then what's an ion? It's got a charge because it has done what? Lost or gained electrons. And that's exactly what we're looking at. Polyatomic ions, when we write their formulas, the formula will be in parentheses, and then the charge will be on the outside of those parentheses. So there's an additional step, and really what this is not at the end of the process, it's at the beginning. It's when we count valence electrons. We've got to take into account if we have a charge, because as Colton said, we've either gained or lost those electrons. Now, what type of charge gains electrons? Negative charge, okay? And then positive charges will lose those electrons. So right here, when we count up our electrons, if it's a positive charge, we're going to subtract that number from our total electrons. If it's a negative charge, we're going to add it to our electrons. Okay? So make sure you take a note of that. Also, since we're dealing with ions, just very similarly to ionic compounds, when we drew those structures out, we've got to have brackets around our substance. Why? Because it's showing that the gain or loss of the electrons is in the total. It's distributed between all of the atoms in that molecule. Okay? That charge goes over all of the atoms, not just one piece within it. So let's jump in and do an example here together. I'm going to give myself some more space. All right, you may want to use a separate sheet of paper for this because it's going to be some drawing that we have to do.
There's nitrates and nitrogen. Is nitrate just nitrogen and nitrogen ion?
Nope, this is actually nitrate right here. NO3.
Too.
It is nitrate. Okay, so we'll learn about all the naming rules for that, like I said, in our next unit. So NO3 in parentheses with a minus charge on the outside. Figure out number of electrons first. Nitrogen has how many, guys?
5.
It's got 5. Each oxygen brings how many? 6. For a total of how many? 18.
So 23.
Okay. But what else do we have here? A negative. So negative means we've done what? We add 1 to it. Absolutely. Because we've gained 1 extra electron. So we have a total of how many valence electrons? 24. Now think about it. Chloe, you said that how many we had were what? Beforehand. You had said 23, right?
Yeah.
Can we have an odd number, folks? No, because you're existing in bonds and you're existing in lone pairs. All right? At least I should say in this class we're not going to have anything with an odd number of electrons. Okay? So, same process. There's that extra step right there. Now we go through the same process. What's my central atom going to be? Okay? So even though it says step 6, guys, is done in the beginning if we have a charge. If we don't even worry about it. So nitrogen, and then I've got oxygen all around it. Connect them. There's my skeleton structure. So I've added 6 more electrons. Now I've got 18. Where are those 18 going to start going to? The satellite atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. What am I missing with my structure? Nitrogen isn't happy. Before we get there, what else am I missing? What do I have? This is a what? This substance. This is a what? Nope. It's a what? It's an ion, right? So what do we have to have with the ions? We just said it in part 6. And what has to go around it? Brackets. So put your brackets in first so you don't forget that. If you don't have brackets, guys, it's wrong. Okay? It's wrong. And we do have to charge as well. Okay, so like John said, nitrogen needs 2 more. So we've got to form a what? A multiple bond. A double bond in this case. Where am I going to get those electrons from? Which oxygen? Okay, I could take it from the bottom one. Is that the only place I could get them from? So, if I got it from the bottom, this is what my structure would look like. I'd have a double bond down here. Alright, my other oxygens would stay the same. Brackets around it. It would. We're not worrying so much about that right now. We're just going to draw. We're talking about something else here. But yeah, they would. That double bond would kind of force those other 2 oxygens to kind of be spread out a little bit more. But I'm not too worried about that just yet. But couldn't I also get that from here? Absolutely. So that means another structure possibility that I could have. The double bond could be over here. But couldn't I also have gotten it from right here? Absolutely. Folks, this is what we call resonance. Basically, what resonance means, there's a more, formal definition than this, but basically, you can have multiple double bonds being formed in the same structure. Okay? Now, they don't all occur at once, but it's rotating. Okay? All 3 of these structures, if it's said to show all the structures, you've got to draw all 3 of those out. Any time where you can get a double bond from multiple locations, you need to show that. Okay? Because really what's happening in this structure for nitrate is that this double bond is constantly rotating between all of those positions. Okay, the blue, the green, and the pink, all of those are happening simultaneously. That electron is constantly moving, that lone pair, and that's resulting in a lower energy state. Okay, again, it's all about conserving energy when it comes to bonding. So they are constantly shifting and rotating. So it's not just in one spot all the time. Again, that double bond requires more energy to hold those electrons. So if it's shifting, that allows it to be less energy overall for the entire molecule. So resonance, on your Regents exam, if they say to write out all resonance structures that might be possible, you've got to go through and draw all of those. Remember, that double bond is just shifting between these satellite atoms. That's what's happening. There is a shortcut method or way to write in a resonance structure. But if they ask you on your test to show all of them, you can't write the shortcut way. But this is what it would look like for the shortcut way to write a resonance structure. We're going to do basically the same thing we've done. Put your dots all around those oxygens. And then it's a dotted line between them. That dotted line signifies that, hey, this double bond is constantly moving. All right, it's constantly shifting all around. Resonance. Jot it down. Make sure you have that in your notes. You know what that term means. Sulfur has 6. Oxygen brings 24. Now, the negative charge there, what do? You've got to add the 2 because you had that negative 2 charge. It gained 2 extra electrons. Without that, this is a much more complex structure. So we've got 32 valence electrons we've got to use here. What's my central atom going to be? S. Then put my oxygens all around it. Connect them. So there's 8 electrons that I took care of. All right, so I've got 24 others. But before I do that, I want to make sure I put my brackets around my whole structure and I don't forget about it. Excuse me. We've got 24 electrons we've got to use. Each oxygen needs 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. That used all my electrons. Is each atom in my structure happy?
They're so happy.
Absolutely, guys. There's my structure for sulfate. That's it. That's it. So, just because you see a polyatomic ion, folks, does not mean you have to have resonance. Okay? You can also have resonance without having a polyatomic ion. It just depends on the structure. Go through the process and see what you've got to do. So, flip back to page 8 in your notes. I believe it's page 8. Okay, so this chart, guys, right here, I want to just make sure that we went through this. The first 6, linear down through bent. Notice there's 2 bent structures. You need to know these structures. I highly recommend going through and writing out flashcards where you have the name on one side. Then you could draw the picture that corresponds to the picture that's in your notes, as well as the formula for the molecule formula that goes along with the shape. Tomorrow, we're going to start getting into this. Your lab next period, you're going to start to see some of these structures and what happens to them and how they get to be that way. You have to know those and be able to identify the geometry of the molecules based on the structure that you draw, and then the formulas dealing with atoms bonded to the central atom and the lone pairs of electrons.